Okay, students, in this video, we'll discuss about some special functions. This also comes under Introduction to Exercise 1.3 only, but this is general. Everywhere it will be useful. Next year also it might be useful. Okay. So, in that first one, polynomial function. So, what is the general form of the polynomial function? How it look like? How many kinds of polynomial functions are there? We'll see in detail. Okay. The function f r to r is defined as f of x is equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 dot means so many terms are there in between an minus 1 x plus an. So if any function look like this where ai are constants. What is the meaning of ai constants? I means a0, a0, a1, a2, a3 like that. So many number of terms you can put. Is called a polynomial function. So then our function இந்த மாதிரி இருந்தா அதுக்கு பேரு polynomial function. For example, here you see here ax cube plus bx square plus cx plus d. So it is a cubic polynomial because the degree is 3. So, for example, 2x cube plus 6x square plus 7x plus 6 equals 0 is a cubic polynomial. So, ax cube means what? For example, first term, a0 x power n. a0 is 2, x power n is 3. Plus a1 x power n minus 1. Okay, a1 means 6. X power n minus 1, 3 minus 1, 2. Last term you will get a n minus 1x. That is 7x. Plus 6 is equal to 0. So, this is a polynomial function. Why it is called as polynomial function? Because if you see the right side of this equality, this one, okay, it is a defining the function or defining the function. Okay, it is a polynomial. That's why it is called as this function is called polynomial function. This right side is defining the function which is a polynomial. That's why it is a polynomial function. That's it. Very simple reason. Okay, so cubic polynomial. You studied quadratic polynomial also. For example, ax square plus bx plus c is equal to 0, 3x square minus 2x plus 6. So many examples you can write. Quadratic polynomials. 10th standard you studied, 9th standard you studied. So, but quadratic polynomials degree is 2. So, the thing is, the degree might vary. Okay, but last you will get one constant term. an. an is a constant term. So, this is 6 is a an. This is a n. Okay, like that powers will reduce. Powers will reduce. If some of the terms miss, you have to assume yourself. Okay. Next one, very easy function known as the linear function. So, linear function. Very, very easy. For example, if any function which is of the form ax plus b, where a is not equal to 0, but a and b are constants, is called a linear function. Why it is called as a linear function? Because this function, if you draw the graph of this function, you will get a straight line. That's why it is linear. Linear means line. That's why this function is known as a linear function. Okay. So, the function f r to r defined by f of x. What is this representation? This is known as the analytical representation of function. We already saw f of x equal to y or y equal to f of x. ax plus b, where a not equal to 0. Okay. And b are constants. Constant means numbers. Okay, is called a linear function. So I already told why it is called as a linear function, because the graph of this function is a straight line. Okay, that's why it is called as a linear function. For example, y is equal to x plus 3 is a linear function. So many examples you can write. Y is equal to 6x minus 4. Anyway, any number of examples you can write. Okay, but if you plot the graph of this one taking x values, okay, and y values, simply you will get a straight line. That's why it is called as a linear function. Next, rational functions. This also is studied in 10th standard. Rational function. What is a rational function? If any function which is of the form p of x by q of x is called a rational function. Suppose I am defining a function f of x, which is nothing but, for example, 3x square plus 2x by 6x plus 7. It is a rational function. This is p of x, this is a q of x. But whenever you will get in fraction form, the denominator should not be equal to 0. Q of x should not be equal to 0. Even we saw in domain also. Domain means what? This function is defined for all the real values of x except the value in which the denominator is 0. So அதுக்கு ஒரு பேர் வச்சிருக்காங்க rational function. Rational numbers p by q form. So rational function also p of x by q of x form. That x only varies, that's it. Okay, rational number, you know, a number which is of the form p by q. So here p of x by q of x, that's it. That's why it is called as a rational number. But what is the condition, students? Q of x not equal to be 0. Okay, so now the domain of this function, the domain of this function is set obtained from R, that means every real value, by removing the real numbers at which q of x is equal to 0. We saw so many problems, exercise also, cos problem, sine problem, find the domain of, find the range of. Domain of means if it is in division form, you should remove the values from R in which the denominator becomes 0. That is known as the rational function. So we saw polynomial function, we saw rational function, and one more function, what you saw? Linear function. So now we will see the reciprocal function. This is also very easy function only. Okay, like for example, x is one value they given. Then what is a reciprocal means 1 by x. Same way in the function also. For example, g of x is one function. Then reciprocal means what? 1 by f of x. So it is called reciprocal function. So the domain of G is a set obtained from R, again same thing, by removing the real number at which f of x is equal to 0. So this f of x 0 values, it won't be defined, because something by 0 infinity. For example, f of x is equal to 1 by x minus 1. So what is the possible domain here? Every real value x can take except 1. 1 edutha 1 minus 1 0 agum, 1 by 0 infinity agum. That's why the possible domain is every real value capital R, but except minus 1. Okay, that's sums we saw in sin x problems, cos x problems. For those values of x, it will not be defined. Okay, next one, exponential function. Okay, students, exponential function. See, exponential function means generally any function, okay, in which x is present in the power. Power means m power n, like that. Then it's called an exponential function. For example, f of x to a power x is called an exponential function. Why it is called an exponential function means as the value of x increases, the graph will move upwards. It increase aite poite irukum. That's why it is known as an exponential function. As x increases, the graph also moves up exponentially. That's why it is called as an exponential function. So f r to r defined by f of a power x is called an exponential function. It's called exponential function. So e power x, e power minus x also exponential functions, but e lies between 2 and 3. That's why, for example, if I take the graph y is equal to 2 power x, this is yx equal to 2 power x graph. This is y equal to 3 power x graph. So it is increasing, it is rising. Okay. Then e power x lies between 2 power x and 3 power x. You see here 2 power x and 3 power x. E power x graph is there. Suppose if you consider 3 cases, for example, a is equal to 0. 0 power something, 0 only. So if a 0 means it is got 0 function. Then we value kandipudikka mudiyadhu. If a 1 means it is a constant function, because if f of x is equal to a, we saw the definition of constant function. A power 1, a only. So constant function. Next, a greater than 0. A greater than 0 means what? 2 power x, 3 power x, 4 power x, 5 power x, 6 power x. These are all called as exponential functions. So a 0 means we cannot get the function itself. 0 power something 0. A is equal to 1 means constant function. F of x is equal to a. A greater than exponential function. This is a graph of the exponential function. It is increasing, it is rising. Okay, it is going on increasing like this. That's why exponentially increases, raises. Okay, but e power x, e power minus x also known as the exponential functions, in which e lies between 2 and 3. It's going to 2.731 something e value. That's why it lies between 2 power x and 3 power x. So this is just simply, you should know how the graph of exponential function should will look like. That's why I saw this, we saw this graph also. Okay. So last function we have something known as logarithmic function. This is also known as exponential function, but the main thing is it is defined only for positive values. That means positive values means what? 0 to infinity. For 0 to infinity to r, this is a domain 0 to infinity. Codomain is full real value will come. Okay, because log 0 also defined. You understand? Log 1 0. Okay, so the function f0 comma infinity, this they might ask in 1 mark also. What is the domain of logarithmic function? 0 comma infinity. Defined by f of x log x base a is called logarithmic function. Okay, the inverse of an exponential function, generally known as the logarithmic function, but you should take suitable domain 0 comma infinity. A power x we already saw. If you take the inverse of that a power x, it becomes a logarithmic function only. So students, for the graph you can refer the textbook. Okay, but anyway, this logarithmic function you are going to see deeply in chapter 2. That's why I didn't explain much, but you should know at least the domain. Okay, domain is 0 comma infinity. Log x base a. X can take only positive values. You can define logarithms only for positive values, not for negative values. Okay, just you remember this one. And one thing you should remember, what is the inverse of this exponential function? Logarithmic function. Okay, so this chapter up to this, it's enough for you. Okay, anyway, in basic algebra we are going to see this logarithmic function, properties of logarithmic function, product rule, quotient rule, reciprocal rule. Okay, all these things we are going to study in a basic algebra chapter, last exercise. Okay students, so if you like this video, please subscribe this channel. Okay, bye.